All right, our last section in week 1 is going to begin chapter 1 in our book on graphs and graphing utilities. And so hopefully this is, again, somewhat of a review if you've done algebra and geometry before on plotting on a coordinate plane. So we're going to maybe go a little quick through this. This section will be introducing us to the coordinate plane. This is two-dimensional number lines which intersect at right angles. The horizontal axis is called the x-axis, and the vertical axis, or the vertical number line, is called the y-axis. Every point corresponds to an ordered pair, is what we call them, because the order does matter of both of them, represented by, normally we have an x comma y, so we do the left or right axis first, then our up and down axis. And this intersection, the intersection point of these two number lines is called the origin. And the corresponding point to this, if we intersect there, we're going to be at 0, 0. Notice we do have some negatives here, so that is the 0, 0 point. The plane is then divided into what we call quadrants, and there are 4 of them. So, if we ever refer to anything in quadrant 1, that is this one in the upper right-hand corner, then we go counterclockwise. So this is going to be quadrant 2. Then we have quadrant 3 down here. And quadrant 4 is this guy over here. Okay, now let's explore how to plot points. Make sure you move left or right first, and then in the y direction, which is then up or down. And it is determined about whether it's positive or negative, whether you go up or down or left or right. So if I want to plot point A, here's my x and there's my y. So on my x-axis, I need to go left 2 because it's negative, so here's at negative 2. And on the y-axis, I need to go to positive 4, which is in the up direction. 1, 2, 3, 4. Place a point there. I'm going to go ahead and put a letter A there, so you know that that is point A. Point B. Can we plot the point 5, negative 3? So in the x direction, go positive 5, which goes over here. And in the y direction, we're going to go negative 3, which means I need to go down 3. 1, 2, 3. This guy right here then would be point B. Point C and D are what we call axis points, and so they're actually going to lie on the axis. Notice that we have zeros in spots. So that means we're not going in any direction for the first one, not going anywhere in the x direction, but I'm going up 5. So for a 0, nowhere on the x, starting at the origin, go up 5, 1, 2, 3, 4, 5. That would be my point C. And for this one, we have negative 4, 0. So that means from my origin, that's where we're always going to start. I'm going to go over 4 to the left, negative 4. Don't go anywhere up or down. It is right on the axis, and that would be letter D. Okay? So hopefully that's a quick little review there of our coordinate plane and some of those axis points. Okay? Now that we have plotted a couple points, we're going to use this idea in order to start graphing some equations. So a relationship between two quantities can be expressed as an equation in two variables. Equation equals, okay? A blank, a solution or answer to the equation is an ordered pair that satisfies the equation, or it makes the equation true. So for instance, if I have the equation y equals x plus 2, and I have the point 1, 3, that would be a solution to this equation, because if I put the x and the y values into my equation, I get a true statement. So y is 3, so is 3 equal to x is 1, 1 plus 2. Is that true? Yes, it is. Therefore, this is a solution or an answer to that equation. And so we could plot that point, and it's going to have multiple points that work for each equation. So let's do this, and we're actually going to be nice and give you the x values that we want you to use on those, okay? So the easiest way to do this is to do a T-chart, okay? So I'm going to search with the t-chart, go X and Y, and they give me the domain to be the x's of -2, -1, 0, 1, and 2. And I'm going to now plug those in to my equation to kick out the y value. So I'm going to take -2, plug it in, square it, and add 1. So what is -2 squared? Add 1. Well, this gives me a +4. Remember, anything squared is always a positive. Plus 1 gives me a 5. If I put -1 in there and I square it, I do get a +1. Plus 1 is a 2. So a lot of times you can do it in your memory, or you can write it out like this. 0 squared is 0, plus 1 is 1. 1 squared is 1, plus 1 is 2. And 2 squared is 4, plus 1 is 5. So notice here, we get kind of some common numbers there. All right, so if I want to plot -2, 5 in the x direction, -2, up 1, 2, 3, 4, 5, that gives me this point. -1, 2 gives me this point. From 0, we're going to go up 1, gives me this point. Hang on. Okay, gives me this point. Then I end up going from 1, 2, so from the origin, go over 1 and up 2. And from the origin, sorry, that's frustrating. Okay, over 1 and up 2. And then the last point is 2, 5. So from the origin, go over 2 and up to 5 gives me this guy. And we are going to connect those points. This is actually what we call a parabola. It is in the, oops, I didn't go through that last one. It is in a U shape there, and that gives me my graph. Okay, so we're going to do that for each one of these, just to kind of get an idea of what some of these common graphs look like. All right, X and Y. We are then going to plug in -2, -1, 0, 1, and 2. This is where your scientific calculator may be helpful for you. If I plug in -2 times -1/2, well, negative times negative is a positive. Half of 2 is 1, so 1 minus 1 is 0. If I plug in -1, -1/2 times -1 minus 1, well, this ends up giving me a fraction, but that's okay, don't flip out. Here we have a +1/2 minus 1, which is -1/2. If I plug 0 in, 0 is always the easiest because this term goes away. Minus 1 gives me a -1. Then if I plug 1 in there, now think of it this way. I have a +1, so -1/2 times a +1 is a -1/2 minus 1, which gives me -1 and 1/2 is the easiest to use when graphing. And if I plug 2 in there, -1/2 times 2 is a -1. Minus 1 gives me a -2. And these are the numbers that I'm going to plot. Now let's see what we get when we do that. If I start at the origin and go -2, 0, that means I'm right here. Start at the origin, go over -1, down 1/2, so that gives me about here. At 0, I'm going down -1 for the point 0, -1. Go back to the origin, go over 1, down 1 1/2, which gives me about there. And from the origin, go over 2, and -2 gives me this point right here. So what I have is a line this time. Anytime I have powers of 1 and 1, that's going to be a line that then I'm going to connect. And notice we put arrows on both sides, so that it keeps on going forever and ever and ever. Okay? All right, next one. We have an absolute value of x. The absolute value of x within there, remember, that's our distance from 0, and it makes any negative number positive. Okay, so I have my t-chart here. And we're going to put in -2, -1, 0, 1, and 2. And so, if I throw in -2, the absolute value of -2 is a +2. Times a -2 here by the order of operations means I get -4 plus 2 is -2. Again, you can write it out if that helps you. Please do so. If I plug in -1, the absolute value of -1 is +1. +1 times -2 is -2 plus 2 gives me 0. Again, if I throw 0 in there, that whole term is gone to 0. Plus 2 is 2. If I throw 1 in there, absolute value of 1 is 1 times negative 2 is negative 2 plus 2 is again 0. And if I throw a positive 2 in here, you're going to get exactly what you got here because absolute value of positive 2 is 2 times negative 2 is negative 4 plus 2 is negative 2. So what does this look like whenever I graph it? I'm going to start at negative 2, down to negative 2 also, put a point. Negative 1, 0 at the origin, go over negative 1, nowhere in the y direction. From 0, I'm going to go up 2, gives me this point. Then I'm going to go over to 1 and not in the y direction, so 1, 0. And then go over 2 and down 2 gives me this point. Now, it looks very similar to the one we did up here with our x squared, but you should learn that an absolute value function, if we did everything in between here, it's actually going to be a V shape. The x squared gives me a U shape. The absolute value gives me a V shape. So make sure that you see that. All right, let's go to another x squared. If it's an x squared, it's probably going to be some kind of U shape. So let's go negative 2, negative 1, 0, 1, and 2. Again, we're going to plot these values in, remembering that anytime I square a number, it becomes positive. So I get 4 minus negative 2 squared. Negative 2 squared is 4. 4 minus 4 is 0. If I throw negative 1 in, negative 1 squared is positive 1. 4 minus 1 is 3. If I throw 0 in, that's awfully nice. 4 minus 0 is 4. If I throw 1 in, 1 squared is 1. 4 minus 1 is 3. So I get these being the same. And if I throw 2 in there, that should be the same as when I throw negative 2 in because 2 squared and negative 2 squared are 4. 4 minus 4 is 0. So let's plot these points to see what our parabola or our U shape looks like here. So go from the origin, negative 2, 0. Negative 1, up 3. Don't go anywhere in the x, so 0 up y value, which is 4. Go over 1 and up 3. And over 2 and not anywhere in the y. And again, that kind of almost looks like our absolute value, but again, this time it's a U shape. It's hard for me with this pen to get through those dots, so make sure you're kind of a little bit more accurate than I am. All right, so we've seen 2 U shapes, a line, a V shape, and now we get an x cubed. So again, we're going to use negative 2, negative 1, 0, 1, and 2. So we're going to throw negative 2 in and cube it. So negative 2 times negative 2 times negative 2 is negative 8. Minus 1 is negative 9. Well, that's going to be unfortunate because it's going to be off our chart. But negative 1, throw in there, gives me negative 1 times negative 1 times negative 1, which is negative 1. Minus 1 is negative 2. 0 in there, that term goes away. Minus 1 is minus 1. 1 in there, 1 times 1 times 1 is 1, minus 1 is 0. And 2 times 2 times 2 gives me an 8, minus 1 is a 7. So these are the points in this case that I need to plot. Again, negative 2, 9 is going to be somewhere down here maybe. Well, maybe down here more so. And then negative 1, negative 2 gives me this one. 0, negative 1 is here. 1, 0 gives me this one. Be very careful on those axis points. And 2, 7 would get me about there, possibly. Okay? So this is the graph that I like to refer to as a squiggle, because you end up having kind of a little curve within that, a little squiggle per se, when you have an x cubed. Okay? All right, so again, these are just some basic ones that you will see. Other kinds, if there's an x cubed, then it should have some kind of little squiggle like this that's going to model one similar. All right, let's try this one with y equaling negative 3. Well, this one's a little strange because it doesn't have an x in it. And that's okay. So it doesn't matter what x I choose. It's telling me that y equals 3 no matter what. So if I want x to be negative 2, this is going to be 3. Negative 1 for x, y is 3. This is 3, that's 3, and that's 3. So what I've now done is created some points on this graph. Let's graph it. What do we get? Negative 2, 1, 2, 3 gives me this point. Negative 1. 1, 2, 3 gives me that point. 0, 3 gives me this point. Hopefully you kind of see what's happening here. 1, 3 gives me that point. And 2, 3 would give me this point. So what I end up having is a nice horizontal line. And we will talk about that later a little bit. But if you start thinking about this horizontal line will end up going through the y-axis. And we have a y equals there. That's a way to remember that. So if I had like x equals 5, that's going to be a vertical line going through at x equaling 5. But this is what you need to know right now. Just plugging in those points and kicking out those values, and we have that line. All right, our last graph here, y equals negative 1 over x. And again, we're going to be plugging in the values of negative 2, negative 1, 0, 1, and 2. So when I plug in negative 2 here, negative 1 over negative 2. So remember, you can have those double negatives become a positive. So this is going to end up being a 1/2. When I throw 1 in there, negative 1 over, a negative 1. So if I think about that as a negative 1, then I get a positive 1. What happens when I throw 0 in there? Negative 1 over 0. I'm hoping you're looking at that going, that looks a little strange. Because remember, you cannot divide by 0. You have to have 0 on the top for it to be equal to 0. But this, ladies and gentlemen, is what we refer to as undefined. Okay? And when I throw 1 in, so now if I put a positive 1, negative 1 over positive 1 is a negative 1. And if I throw 2 in here, I get negative 1 over 2, so negative 1/2. These are the points we're going to plot. And then we'll kind of see what the rational graph of 1 over x looks like. So negative 2, 1/2 would be about here. Negative 1, positive 1 is here. We don't have any points here. This is undefined, so nothing's going to cross that line. And then at 1, negative 1, I have this point. And at 2, we have negative 1/2, which is about here. Now, anything that looks like a 1 over x, it is going to be kind of some curves that are going to be approaching two different lines here. First off, this vertical y-axis, and it's actually going to be approaching the x-axis. So it's going to end up, if you keep plotting more points than what we gave you, looking something like that. So again, something to get familiar with. We will work with that later on. All right, so when it talks about, there's some intercept work, it says when graphing the x-intercept and the y-intercept, these are some terms you'll want to know. They are key features in a graph. The x-intercept is where the graph crosses the x-axis, and the y-intercept is where the graph crosses the y-axis. Now, let's go back up into our graphs above and identify both the x and y-intercepts in each if they exist, okay? So we need to do that. Let's go back up here. See where we cross the x-axis and the y-axis, okay? So I'll do this kind of in blue so you can see that. Where do we cross the x-axis? Hopefully you're telling me there is none. So for an x-intercept, there aren't any. For a y-intercept, we end up having, that guy right there crosses the y-axis, so that is equal to 1. If I look for my x-intercept here, where do I cross the x-axis? And the y-intercept, where do I cross the y-axis? Notice here, right there is the x-axis, and my pen's going crazy. And so that is at negative 2 for the x-axis. And I look along the y-axis where it crosses, it's going to be right there at negative 1. So sometimes you might not have any. Sometimes you'll have both. All right, x-intercepts. Sometimes you'll have 2. Notice here it crosses 2 places, 1 here and 1 here. So I have negative 1 and 1. And for the y-intercept, I end up having this guy right here at 2, would be my y-intercept. What is going on? Okay, -1 and 1. Y-intercept is at 2. Look at this graph. I have x-intercepts at -2 and 2, right here and right here. And I have a y-intercept. Where is it crossing the y-axis? It is right there at 4. Very good. The next one, I have an x-intercept here at 1 and a y-intercept here at -1. For this graph, y equals 3. Do I cross this x-axis? Heck no, because I'm parallel to that axis, so there are no x-intercepts, but there is a y-intercept at 3. And notice here on this one, we are approaching the x-axis in both directions and approaching that y-axis. So for my x and y intercepts here on this graph, there are actually none. So remember, these are where we cross the x and the y-axis. Sometimes they're very, very easy to find. Other times they're hard to kind of determine if the graph is not very accurate. All right, so the last little part of section 1.1 is talking about writing words into symbols. So there's a couple things that I want you to remember of some things that they mean. So I want you to remember that is in words means equals. And when you have more than or less than in a statement, I want you to put this at the end of the expression. So I have, the first one says the y value is 2 less than the square of the x value. The y value, so y. Then I come to is, which tells me that means it equals. Then I have the expression 2 less than. That's what I'm telling you here. You have to put those at the end. Now, not so much with the plus or the more than, but with the less than, it makes a big difference. Less than means subtract. More than means to add. So that means I have to be 2 less than whatever it says here at the end. And it says the square of the x value. So in order to represent that, I'm just going to write that as x squared. So the y value is equals, so the y equals 2 less than goes at the end, the square of the x value. X squared is the way we would write that mathematically. So there's the equation that we just interpreted out of that sentence. And the last one, we have the y value is, so I'm going to say y is, or y equals, there goes my crazy pen again, y equals is the difference between 5 and 3 times the x value. Now this is a little bit different. It doesn't say more than or less than. We don't have to go at the end. We're going to take it from left to right. Wants to know the difference. Well, sum is add, difference is subtract, product is multiply, quotient is divide. So here we have a difference between 5 and 3 times of x. So I'm going to do 5 in the first and 3 times the value of x. Basically, we're going to just write it mathematically as 3x. So making sure you're able to work from symbols and words, or sorry, words into symbols, and also vice versa. Okay, so that's section 1.1. Again, I hope that's somewhat of a review. Again, it might have been a while, but hopefully some of this is coming back to you. So until next time.